This is Jambo Radio.
Hello, and welcome to the Science Show with Dr Dada on Jambo Radio Scotland, broadcasting from the city of Glasgow. Of course, as you know, on this show we explore science and technology in various forms, various aspects of it. Especially, we explore the implications these developments in science and technology have for our everyday lives. And this includes science behind some phenomena, some everyday phenomena, and some maybe not so common phenomena like floods. Okay? And so that's why today's show will have an interesting topic: the science behind floods. Okay, that's what we're going to be talking about and exploring in this show. So we're going to look at floods, why they happen, how they happen, and we're going to be looking at the effect these have on the environment and on people. And believe it or not, there's a lot of science and technology that goes into discussing and actually studying these effects and this topic. So what branch of science will that be then? Well, last week we talked about virology, didn't we? This week it's going to be hydrology. We're going to understand what that means because we have an expert with us in the studio who's going to explain that to us. So what's the question of the week then? The question of the week is floods. Why are they getting worse? So why are floods getting worse? Of course, with that question comes the assumption that actually floods are in fact and indeed are getting worse. So is that really the case? Well, we're going to explore that as well on today's show. Well, I'm your host, Dr. Adetunmise. I'm a lecturer in optics at the University of Glasgow, and this is the Science Show on Jambo Radio Scotland with Dr. Dada. So, don't forget you can listen to us on DAB, that's digital audio broadcasting. So whether you're in the car, whether you're at home, if you have a digital radio, you can enjoy this show live. And also you can watch us live and listen to us live through the website jamboradio.co.uk and also by means of our app where you can listen to the show. So please follow the Jambo Radio Scotland channel on YouTube for episodes and updates about the show. So what can we look forward to today on the show? Well, as usual, we're going to start with some highlights in the world of science and technology. And then after that, we're going to have an introduction, an interview with our guest. We're going to get to know them, get to know who they are, what their background is, and so on. And then after that, we're going to have a discussion with them on why floods are getting worse. So this will be part of the guest interview as well. And then the part 2, we're going to talk about the research activities of our guest. We're going to talk about their, the different things they're involved in and projects and so on. So we'll be looking forward to that. And in the show, during the discussion, we'll be also receiving calls from viewers and listeners. So you can contribute to this topic and the answer to this question: why are floods getting worse? We would like to hear your opinion on that as well. And as usual, we're going to end the show with some fun activities. So we're going to be vibing to a STEM beat today. We're going to rap to it or maybe sing a song. We'll see what happens with that. And then hopefully we'll enjoy a couple of jokes as well. So that's something to look forward to. So very good. Before we have our news highlights today, let's have a look at who we're going to be having on the show. So let's introduce quickly our guests. Today we have Mr. Christopher Masafu. Christopher Masafu is a PhD student in hydrology and he studies at the University of Glasgow. So welcome, Christopher.
Thank you very much.
It's really nice really nice to have you in the studio with us today.
Glad to be here.
Yeah. So what's the name of the school you're in the University of Glasgow?
So I'm in the School of Geographical and Art Sciences.
I see.
Yeah.
That's a really interesting one. And is that in the College of Science and
Engineering? Yeah, that's in the College of Science and Engineering.
Fantastic. So you're from Kenya, aren't you?
Yes.
Great. So you speak Swahili?
Pretty good Swahili. Yeah.
Fantastic. So is Mufasa Swahili?
Mufasa, not really. I think that might probably have South African origins.
I see.
Bantu name.
Interesting. So your name is Musa.
Masafu, yeah.
Yeah, it reminded me of Mufasa.
Yeah, if you play around with that,
you rearrange the letters.
Yeah.
Interesting. Anyway, I love African languages. I love Swahili. I love Lingala very much. So I mean, if you grew up in Nigeria the way I did in Lagos, you probably know Wamilele. You know, like a few words. So Wamilele is Swahili, isn't it?
Yeah. I love Lingala as well. By the
Yeah.
way, it's a big cultural export from Congo to East Africa.
Yeah, absolutely. And I love to discuss science in African languages. So maybe we'll get to do a little bit of that today.
Yeah, we'll try.
Fantastic. So yeah, a lot about languages. Anyway, maybe we'll save that for later or maybe for another show. We welcome you, as we said earlier. So really nice to have you on the show. We're going to learn a lot from you, obviously, about floods, what causes them, and how hydrology and the science, and technology resulting from that can help reduce the impact of floods. So once again, the question for the week will be, why are floods getting worse? Okay, so that's something that I would like you to think about as well as a viewer or listener at home, and feel free to call us during the show. The lines will open after the news highlights, but just to keep it in mind, the number to call is 0743 782 6865. So once again, 0743 782 6865. All right. So just a couple of headlines then. Let's have a look at some news highlights. So on the list of headlines that caught our attention today, the first one is actually almost scary, actually, to be honest. When I saw this, it says human neurons grow in rat brains in first human rat brain hybrids. So I don't know what you think about this, but I find this a little bit it's interesting, definitely interesting, but I find it a little bit worrying. But for reasons I'll explain later. Anyway, so what does the report say? So there's a report on Fierce Biotech by Helen Flush, and it says, scientists at Stanford University have transplanted human brain cells into rats. These human rat brain hybrids could be used to study conditions like autism and schizophrenia, potentially marking a major turning point in scientists' ability to develop effective treatments. So, in some ways that's interesting, isn't it? It's a positive development. But here's what Professor Sergiu Pasca, a co-corresponding author and director of Stanford Brain Organogenesis, told reporters in an online press briefing. The human brain certainly has not been very accessible, which precluded the progress we've been making in understanding the biology of these conditions. That's why building human models that are non-invasive of the human brain is one of the most promising avenues to trying to tackle these conditions. So this study was published in Nature, September 12. So it's something you can actually have a look at. But thinking about the ethics of this, as obviously you can see the picture there as well for those who are watching us live, watching the video. So you can see a part of the brain. That brain is actually the brain of a rat, and the brighter green part of it is actually the human neurons. So the human cells glow in fluorescent green there, and that image is by courtesy of Stanford University. But it just makes you think. So where is this going to lead, or what are the kind of ethical issues surrounding this kind of study? So yeah, it's quite interesting. So the description of that image actually says that that part of the brain. So the scientists implanted organoids of human neurons in rats, somatosensory cortices, the part of the brain that receives signals from their sensory organs, including their whiskers. So yeah, I'm just wondering where this kind of leads. So if we kind of think about it, it sounds like a theme for a very interesting horror movie. So where the rats kind of become intelligent, super intelligent, like maybe humans, maybe having the kind of consciousness that humans have, and all kinds of horrors can unfold from that, obviously. But anyway, let's move on to the next one. The next headline is Nigeria flooding kills more than 600 people and displaces 1.3 million. So this is obviously a very worrying news. But the BBC, according to the BBC, says overwhelming disaster leaves more than 600 people dead as well. And 600 people, that's a lot of people, isn't it, dead. And it's reported that this is actually the worst flooding in Nigeria in a decade. So obviously something needs to be done about it. And of course, that's why we're going to be talking about that today, hydrology and its impact on when it comes to mitigating the effects of floods. Anyway, so the next headline says, for the first time, astronomers saw dust in space being pushed by starlight. So that's quite interesting, isn't it? Because, when it comes to the effect, the radiation pressure due to light, it's something that's not very easy to observe because the effect can be very, very tiny. But now, for the first time, it's kind of been demonstrated that actually light can, affect the movement of particles in the cosmos. So it says that the finding could help researchers understand how light sculpts matter throughout the cosmos. Shells of dust form when winds from these two stars in the Cygnus constellation collide, and as seen in this image from the James Webb Space Telescope, the shells are then blown outward by the pressure of light from those stars. Now, this pair of stars in our galaxy, being able to see them in more clarity is revealing how light pushes around matter. And that's a very, very interesting thing. It's the first time anyone has directly seen how the pressure of light from stars changes the flow of dust in space. So talk about stardust, right? Now, you can read more about this again in Nature. This was published in October this month, on the 13th of October. Okay. So another headline on floods: 2 men missing in NSW flood waters as Gondagai braces for worst flooding in 33 years. So that's news from Australia. Just to highlight that this whole flooding situation is not isolated. It's not just in one place. I remember back in 2021 as well, a lot of flooding happened in European countries. So definitely there seems to be a trend when it comes to the occurrence of these kinds of floods. So that brings us back now to today's topic, hydrology. And we're going to, as we said earlier, we're going to be learning a lot from Chris Masafu, who we have in the studio today. So let's get to know Chris then. Let's talk to Chris and get to know him a little bit. We're going to just get to know you, Chris. Once again, it's nice to have you in the studio. But we'd like to get to know your background, your family life. Obviously, that was in Kenya, and how you how you got to be in Glasgow for your studies.
Yeah. So thanks very much, Dada, for having me today. So like you said, from Kenya, spent the formative years of my growing up in Kenya.
Yeah.
Studied for my bachelor's degree back in my country at one of the public universities. And then I was a bit lucky right after that to come over to the UK at the University of Bristol, who are at the forefront, by the way, of this flood mapping studies. There's a really big startup over there called Fathom, and they're doing a lot of great work, independently and with NASA, as well as with the World Bank on mapping floods. So when I was there, I met a really interesting gentleman who's presently at the University of Leeds. He's called Dr. Trigg. And that kind of just, spurred a real interest in the modeling of floods. So finished that. That was way back in 2012. And then I went back home and I was working for a period of around 6 years. Interestingly enough, in the oil and gas industry, which was just starting to take off in my country. So I was straddling another slightly different field of hydrology called hydrogeology. So I was doing that and some bits of geophysics as well for the company that I was working for at that time.
I see.
And I was kind of waiting for the right opportunity to come up because I'd always wanted to do a PhD. So at sometime in 2019, I saw this project advertised by the Uni of Glasgow. Applied to it, and I got into it. So again, I guess I was lucky or something. So started off late 2019 and just coming towards the end of the PhD. So should be done in likely the next 8 or so months. That pretty much sums up my background really, generally.
That's interesting. Thanks for sharing that with us. So it's just really interesting that you mentioned you were at the University of Bristol.
Yes.
Because I was there as well. So what years, remind me, so that was, you spent 2 years in Kenya after that?
No, actually, after Bristol, I spent 6 years in Kenya.
Wow, okay, so it was much, it must have been much longer before I was there.
A year.
So when did you leave Bristol then?
So I left Bristol in 2013.
Oh, wow.
Then went back home. So spent 6 years, then 2019 I was back in the UK.
I see. Yeah. Wow. So that's so I was in Bristol from 2016 to 2019.
Yeah, a little later then.
Yes, indeed. Fantastic. So it's really great. So what inspired you then to do STEM? I'm sure that happened in Kenya. Right. So would you like to share that with us?
Yeah. I'd just like to correct something, by the way, that you mentioned as you started off, that floods are rare. Actually, floods are the most commonly occurring natural disaster. So, compared to earthquakes and all these other things, tornadoes, hurricanes. So floods are the most frequently occurring one. And they're a very big deal. There are lots of people who study floods, not too many of us in the field. Actually a good chance for anyone who wants to dive into hydraulic modeling. There's a lot of market for that, pretty much globally. Even now, as I speak, I'm kind of fighting in between, definitely finishing off with my thesis, but, getting some work, and there's plenty of that out there. So the thing that inspired me, like I'd say, met this gentleman who's pretty much a mentor at this point as well, who was doing a lot of work for the World Bank at that time, and he roped me in, and we still work with him to date. So just looking at the devastating impacts of floods across the globe, just made me want to join in and hopefully be at the forefront of devising this novel, good solutions to how we can cope with the floods, because they're only going to get worse with climate change. So that pretty much spurred, my interest into getting into modeling floods and seeing how we can best manage, the impacts of flooding, because they're only going to get worse over time.
Oh, wow, interesting. Thanks for sharing that with us. Yeah, by the way, when I mentioned rare in regard to floods, I wasn't talking about, compared to other natural disasters. I was talking about compared to things that are impacted by science, like everyday things. So there are everyday things like, using the mic, lights, technology like phones, but then there are floods that you don't encounter every day, hopefully, right? So that's the context of it being rare that, I mentioned. This is the Science Show with Dr. Dada on Jambo Radio Scotland, and we're broadcasting live from the city of Glasgow. Again, don't forget you can listen on DAB, and you can also watch us and listen to us live on jamboradio.co.uk. So let's get back to our chat with Chris Masafu. So we're getting to know you. You told us a little bit about your background, which was really nice and interesting. But could you tell us a little bit more about your PhD research then? So that is basically your current research that you're doing. You mentioned one or two things already about it, but would you like to just expand a little bit further on that?
Absolutely, yeah, I'd be happy to. So the core focus of my PhD is to use a synthesis of satellite video artificial intelligence and physical flood models to improve our capability of mapping floods and flood risk. So one of the study areas that I'm working with is interesting. It was in the news highlights. Is in New South Wales. So we firstly run a little bit of a proof of concept here in the UK in the Lake District.
Yep.
And we scale things up. So just to get back to it for so that people could kind of understand what that is. So generally, when you're thinking of floods, we like to model them. So a lot of there are lots of consultancies and people who do that, myself included. So modeling floods means we try and simulate this flood events before they occur, and we're trying to see three key things. So one, what are the velocities that we'd expect when the flood waves arrive at location X? What will be the depths of the water at that place, and what will be the inundation extent? So how far would the flood waters go? And some floods can actually be very devastating, like you mentioned right now in Nigeria, in Cameroon as well, Chad, Australia as we speak right now, and quite recently in Brazil, we did a bit of work there with the World Bank, modeling floods for a city there, as they try to put in interventions. So we've got this mathematical or physical models that we'll feed them with data, and then they'll give us predictions of what we can expect to occur, and we can play around with many scenarios. You could put in climate change scenarios into it, and that will tell you how exacerbated these flood events would be. So what we're trying to do with my PhD now is normally you have to correct these flood models because they're just mathematical predictions of what could occur. So there is a process called validation, and to validate the model is simply to take a look at the model prediction and then subject it to some rigorous tests to make sure that the predictions that it's giving you are accurate. And this is really, really critical, validating this model. So what my study is doing is we're using satellite video, and satellite video is actually quite a new frontier in terms of remote sensing data, because at present the current state of the art is the use of still satellite imagery. So you can picture, maybe if you've got your phone, there are lots of satellites which are orbiting the earth as we're speaking right now, and they're taking lots of still images of different places across the globe. So that presently is where we are, but with recent advancements, we now have sensors that have been deployed into low earth orbit. And what these sensors are doing now is they're able to shoot actual HD video from space. And so this is incredibly useful, especially for applications like this, because you can be able to study flood dynamics in real time. And this can be really, really super helpful, especially when you're trying to predict and save a lot of, infrastructure from damage. So a lot of insurers are very, very interested in some of the work that we're doing right now.
Interesting.
So yeah, that without going too much further into it, so this satellite video is really massive. We need a way to be able to process it, and that's where artificial intelligence comes in. So we're using a lot of deep learning algorithms to try and decompose these satellite video frames, which are quite massive, and use them to in near real time feed them into these mathematical models that I spoke about initially, validate our predictions, and then hopefully with that we can be able to make robust predictions of some of the impacts of flood and be able to prepare ourselves well in advance of these events occurring. So that pretty much captures the core of the PhD, and
Nice.
Doing it by publication. We've got a paper that's out right now. We published it 2 months ago, and finalizing on one again, which kind of just will present some of these findings that we've been working on over the last 3 years.
That's fantastic. Well done, and congratulations on the paper as well.
Thank you.
So, yes, that's really good. So I was just wondering, so the mathematical models that you have, what parameters do you kind of feed into the model? So you talked about the speed of the water, maybe the volume of the water, the depth, and things like that.
Yeah.
So what other parameters do you feed in? Do you, for example, feed in parameters to do with infrastructure of a particular place and so on, just to get an idea of how detailed these modeling is.
Yeah. So the modeling is quite specialist, as you'd imagine, but generally some of the key data sets that you'd require, one is the topography. So that kind of touches on what you've mentioned with the infrastructure. So we'll take things called digital elevation models, which are, you can produce those using, these days you can use drones, which is kind of one of the things we did in that paper that I've just mentioned now. Or you can use as well, typically for large areas, like if you're modeling floods, for example, in Nigeria, we'll use satellite imagery to produce this digital elevation models. So based on that models, this model is just pretty much a 3D rendering of the terrain of any place on the earth, and it can come in different, in varying resolutions. So with drones right now, we've gotten to a place where we can capture very highly well detailed topography. And then, with that now, there are lots of other things like stream flow that I'll try to feed into the model, and try and simulate these events. And there's a lot of calibration of other, I guess I would get a bit too sciencey, but, with the terrain or the digital elevation models that I've mentioned, and things like stream flow and rainfall data, if you've got that, we rely a lot on remote sensing data. So this is data from satellites, like I've mentioned, that's really key to the work that we do. So, based off these key data sets, you've got evapotranspiration, a lot of times the rainfall, stream flow, temperature for some models. So, you combine that with the topography that I've just mentioned, and then get into the detail, of the modeling.
Good, fantastic. And what are the results like? So, the results of your studies, how do you kind of quantify that? Do you, for example, quantify it in terms of the impact on people, or is it just results like, okay, this amount of volume of water will be at this particular place and the velocity will be such and such? Or how far does it go when it comes to evaluating the impact on people's lives and property?
Yeah, I think that's an interesting one. So, to respond to that, I think I'll approach it from the angle of, so what? What are we going to do with this?
Exactly.
Model outputs, why do we even need them? So a lot of they're used a lot, like right now, for example, in Nigeria, and a while back there was a big event in Mozambique as well, and quite recently in the state of Minas Gerais in Brazil that I've just mentioned. This is actual work that we've done as well with real impact. So, and Pakistan too, big massive floods. So you've got a bunch of hydrologists who will be sitting behind there working for, say the UN disaster relief team, and they want to get maps of how quickly the flood wave is advancing.
Yep.
So, I've mentioned about the inundation extent. So that's how far the water has spread out onto the floodplain, wherever people are settling. So with these models, I can be able to quite accurately predict how quickly the water is going to get to these guys. And so you can direct your emergency relief efforts properly, and so that you can reach to the right people at the right time. So that's a big part of how it's used, especially so in the humanitarian field. And then insurers also really, they have big teams of in-house, consultants who work on this as well. If you want to build your house, because of population pressures these days, you'll find a lot of people are building into floodplains without knowing it. And, you're sitting in your nice fancy house and, in no time, there's water all over your windows and stuff. So insurers love to have these predictions of floods and their return periods, which will tell them whether they'll set the premiums for example, insuring property and other things that are located at specific places that might be impacted by either coastal floods, pluvial floods, which are from rain, or fluvial floods from rivers. So that, and then as well, the last one that just really quickly, there are lots of applications here. But the last one as well, it can kind of help you when you're designing cities, and we work very closely with civil engineers a lot of the times. In fact, hydrology is just a small bit of civil engineering. It's just kind of being picked out for that. So a lot of older practicing hydrologists are civil engineers, so that they notice it's kind of important, so it was just kind of plucked out. And one other application is when you're planning infrastructure around cities. Of course, you'd love to make sure that you run some models before you start constructing these things. Make sure that whatever you're citing, key infrastructure, is not liable to flooding. And right now, a lot of cities, like the one that I mentioned, we just did with the World Bank, they're trying to build so-called green infrastructure. And with that, you need to factor in how floods would move around places like that. So that's the so what of modeling, and there's a lot as well that goes into it that we'll probably have over another discussion.
Yes, absolutely. So so that's as you said, that's the so what of it. Also, I was wondering, so the actual result that you get from your studies. So for example, what you publish in your papers, there are two aspects. One is to kind of predict the probability of flooding, for example, and another is to maybe predict maybe the impact of flooding. Like maybe there's an ongoing sort of event, and you want to kind of model in advance to respond to that. So what approach do you tend to use in your research? Is it more like just looking at an area and looking at the general kind of probability, likelihood, or do you hone in on some event and kind of try to predict the impact of that event, or do you kind of combine both?
So I think it kind of straddles both. So we try and combine both of them. So we look at previous events that can generally help you. For example, if I'm trying to construct a model for a specific place, maybe Jos in Nigeria, I'll move in there and I'll try and find previous data that I can use to calibrate my model, make sure that my model is working. If I can simulate correctly that past event, then I can have confidence that if I feed in my model and keep the parameters, adjust a few things here and there for changes, as a result of man-made issues, I can be able to arrive at correct answers. So it's kind of a bit of both, really. Try and improve the models over time and look at previous events. Those are usually quite key. But now as well, we're developing really, really good capability. Like I've said, with machine learning and deep learning, it's becoming so important to us, like getting data that can slightly predict events, and then feed this data into our models and see how well they're performing. I think this field of science it's really reinforcing the outputs that we're getting from our models, and I guess that's one of the key novelties as well of the PhD that I'm doing, trying to integrate what is typically the domain of a computer vision scientist into hydrology.
Fantastic, very good. So would you like to tell us then, what does AI bring to the table on this? So you mentioned models. That's basically some computer code, mathematical models, like a way to understand what's going on, like mathematically describing the problem and using the tools of programming, mathematics to predict what the results will be. But I also understand that you use artificial intelligence.
Yes.
So what does that bring to the table?
Yeah, that's a good question. So AI is very critical, and without it would not be able to consume some of these new sources of data. So for example, with the satellite video, like I mentioned, it's really massive data that ordinarily I wouldn't be able to handle on my local machine. And so the first bit of AI, it's really 2 bits for what I'm using in my application. There are many different uses of AI in finance, in agriculture, and here we're just deploying the bits of it that are relevant to us. So we're using a bit of AI called deep learning, like I said. So for us, there's something called super resolution. So we've got these images which have been shot from low Earth orbit by these satellites. And as you can imagine, some of the spatial resolution is lost as a result of the distance from Earth. And so what these AI algorithms help us with is to improve the resolution of this, imageries. So,
Interesting.
like if you've got your phone from back in 2005, that was 1 megapixel, it would take some photos and they would look a bit grainy, which is kind of the thing as well with video from outer space.
Yeah.
So, we can use this deep learning algorithms to step up the resolution of these images. And that's, super helpful when I'm trying to do my validations of the data. So that's one aspect of deep learning. And then the other one is something called semantic segmentation. I don't know, probably with the physicists you might have heard of it or not. It was interesting to see the rat's brain, because this is being used as well a lot in the field of medicine. So segmentation. So what these deep learning algorithms is, what they do is they can learn from really vast amounts of data. You take a deep learning algorithm, train it on really vast amounts of, for my case, I've used art imagery. And so it is able to learn and discriminate features on images automatically. Because right now with the images that we've got with traditional sensors, kind of touches on your field as well. We've got these images, some of them have been acquired in the infrared band, and you've got a lot of processing that you need to do. But with deep learning, with the segmentation, it's able to very quickly tell you this is flooded, that's not flooded, that's a building, that's probably a car, and that's very helpful. But there are a lot of steps that you need to take before you get to that point where the algorithm has learned what it's supposed to do. So those are the two aspects of AI that we've deployed in the study.
I see. Yes. Thank you very much. And I'm sure maybe some of our listeners, if not many of our listeners, are able to relate to, especially the first aspect that you mentioned, because there are apps now that kind of, promise to help you improve the resolution of your kind of low resolution images, and so that's kind of familiar to most or maybe many people.
Yeah.
Fantastic. That's great. So now let's pick up again our discussion with Chris, and we'd just like very briefly to hear your opinion, your expert opinion on the question: why are floods getting worse?
That's a good question. So in my opinion, two things. One, and the science shows this with the increasing climate change. Some of these events, natural events, like the intensity and the duration of rainfall, is getting worse across many places, around the globe. So that's one of the key factors that's driving this. And then two, it's just the explosion in population, which is natural, that's expected. But then there's this huge gap in the earning potential of many people, and so you'll find that a lot of people are settling around flood plains, which is a big issue. If you look around places like Asia, like earlier this year, Pakistan and India, Bangladesh, they've suffered devastating floods where over 1.5 million people displaced. That's a lot of people. And it's just that they're at the wrong place, so to speak. They're forced to settle in these places for many historical reasons, because that's where they could cultivate. The floods bring in this alluvial soils, which are good for agriculture. And most of the times the most vulnerable people are those who've got not very good fiscal earning power, and that kind of subjects them to these events, because if people are not settled in these flood plains, then you don't hear of we heard 1,000 people displaced. So to me, those are some of the key issues that are driving the impacts of this unfortunate events.
I see. That's interesting. It's interesting that you've highlighted kind of two broad sort of issues here. One is the fact that maybe floods are happening more often because of the climate changes in the climate, and then the other is that people are getting more in the way of floods.
Exactly.
Is that right?
Yeah, that's right.
That's interesting.
Yeah.
Good. Thanks for shedding light on that for us.
Absolutely.
So now that brings us to the kind of concluding part of the show, which is where we get to have some fun with the topic that we talked about today, and that's floods and hydrology. So let's start with some science jokes. Do you have any jokes about floods or hydrology that you would like to share with us?
Here you put me on the spot there. Let's see. Okay, I'll try and come up with one, hopefully before the program ends.
Okay. Should I start off with one?
Please do.
So I found these online. Okay, so they're not original by any standard. But anyway, it says, one of them says, "Why must you act quickly during a flood?" Can you guess what the answer is?
Otherwise, you'll be underwater.
Nice. It says because it's an emergency.
Okay.
But the emergency is not the normal kind of spelling. It's emergent C.
Okay. Yeah. Got it. Yeah.
Typical science joke, right?
That's
Another
joke.
one. Yeah, I know. They're all bad jokes. Another one. Stuck in a flood. Don't cry. Why shouldn't you cry if you're stuck in a flood?
Your tears would be lost in the water, I guess.
Well, not bad. It says you'll only make it worse. Right.
Oh, you okay. Oh my God.
I give up. Okay, you're gonna like this one because it talks about you know simulations and stuff. So it says, why do programmers hate designing flood defense simulations?
I'm thinking of something to do with water leaks. I don't know. The code would leak.
Because of the overflow errors.
Yeah. Stack overflow. Yeah. Nice. Yeah, that's a good one.
And then the last one I've got here is, why did all the dogs survive Noah's flood?
The dogs in Noah's flood. No, that's silly. No, I can't come up with anything for that.
Yeah, I know. They were all good boys.
They were good boys.
Yeah.
Yeah.
Boys, float. So.
Oh, yeah, the boys. Oh, BOUIS. Yeah. Okay, yeah. Yeah, good.
Anyway.
Yeah.
Yeah.
No, those are good ones.
Yeah, those are all the jokes I've got, I'm afraid. So do you have any?
And unfortunately, I don't have a
maybe
good
these
rejoinder.
kind of confuse the
No, but those were good. Those were really good. At least I have something now for my next interview.
Exactly. Fantastic. So now let's have some fun with music. Let's look at what our STEM song of the week is going to sound like today. So basically, I made this beat, right? And I think, I tried to compose something in English, but it wasn't working. So I decided to go with Swahili.
Nice.
Yeah. And I thought it's a nice way as well to understand, kind of hear how some science terms sound in Swahili. So for example, what is flood in Swahili?
Flood. So we'll call that mbubujiko wa maji.
Mafuriko?
Yeah, also mafuriko.
Also
that's a simple one. Yeah.
Okay, good. So, because that's the one I used.
Yes. No. That's an even more appropriate one, actually.
Okay.
Yeah.
So, what else do I have here? I have a few other things here. I have. Okay, let me read the first couple of lines before we play the beat, and I'll try to sing it to the beat, but I don't know how that's gonna go.
Nice.
But it says, "Sayansi ya mafuriko." What does that say?
The science of floods.
Okay.
Yeah.
Ulinzi wa mafuriko.
Okay, protecting ourselves against floods.
Kuzuia mafuriko.
Preventing floods.
Kuepuka mafuriko.
To get away or to escape floods.
I can't believe it. I can't believe you're understanding what I'm saying. This is good. Maybe I might take up, learning some Swahili.
Yeah.
What about na hakuna mafuriko tena?
And there are no floods again.
Oh, wow. Fantastic. I like the hakuna.
Yeah.
Hakuna matata.
Hakuna. Oh, yeah. So hakuna is none. Yeah.
Okay. All right. Let's listen to the beat and let's see if I can try to sing one or two lines to it. Great. Science ya mafuriko na ulinzi wa mafuriko, kuzia mafuriko, kuepuka mafuriko, na hakuna mafuriko tana. Akili ya bandia samutuzi ya teknoloji ya akili ya bandia kupozunga mafuriko sasana. Does that make sense at all?
the last bits, I'm not getting them so well.
Okay.
If you could enunciate
Okay,
a bit clearly.
let me read it out first.
Yeah.
So akili ya bandia, matumizi ya teknolojia.
Okay, so that's, I don't know if you're using Google Translate. So it's talking about something to do with the, like if you use fake, brains.
Artificial
and the use of
intelligence.
science. Oh, okay. Yeah.
That's how I know.
think that's Google Translate because it's artificial. Yeah. So bandier is
I
something
see.
that's not original. Yeah. So
I
that's
see.
artificial. So
So
yeah.
so how do you say artificial intelligence in Swahili?
Artificial. Okay. Hapo nitatohoa. So I'll say. Yeah. Actually, that's a good translation of it. So. Taarifa bandia, I would say I'd call it.
You would say that.
Yeah.
Okay.
Yeah.
Interesting. The funny thing is, because maybe it's not a kind of mainstream sort of vocabulary
Yes.
in Swahili, it could be the case that translation is kind of the decided translation by some
It's
group
true, actually.
of translators,
Yeah, because the language evolves over time, and
Yeah.
new words are added to the vocabulary. Yeah. So.
Yeah. Okay, so this is kind of like the beginning part, right? Okay, so let's raise the beat again. Okay. So basically, like, sayansi ya mafuriko, ulinzi wa mafuriko, kuzuia mafuriko, kuepuka mafuriko, na hakuna mafuriko tena. Something like that, right?
That's a good one. Yeah. No more floods.
No more floods.
Floods won't
yeah.
happen again. So yeah, good one. Yeah.
Fantastic. So that brings us to a close on this week's edition of the Science Show with Dr. Dada on Jambo Radio Scotland. So remember, if you'd like to keep your eye on the advances and developments in science and technology and the impacts these are having on everyday life, or maybe you just want to learn one or two things, about science and related activity going on here in Scotland and all over the world, then this is the place to be. Please email us with your questions and comments on today's show and on other shows as well at info@jamboradio.co.uk. And please do check our homepage www.jamboradio.co.uk/the-science-show for news and updates on the Science Show. And we'd like to thank once again our guest for attending and coming to the studio with us today. And we thank you for listening and watching our show, this week's edition of the Science Show on Jambo Radio Scotland. And, with myself presenting, we also have in the studio, we have Zaina Barrow Sherry, we have Otuekong with us on the production team. And next week, we hope to have another guest on the show. So please do stay tuned. Tune in to us same time next week for another exciting edition of the Science Show with Dr. Dada. And until then, stay curious.